guys, we're starting our today's session on food Sherpa, and we had a wonderful session planning today on the food factories. And but before that, let me introduce very quickly about the FST Mumbai, what we are, what we do, and then we start today's session. Okay, very quickly. So we are running behind the schedule, so I will just take very quickly 1 minute to tell you very quickly about who we are. So many of you know about FST, but just to reshare, so FST is Association of Food Scientists and Technologists, is a premier food professional organization in India and represent more than 50% of India's pool of food scientists and technologists. And this is one of the largest professional body or an education organization in India. Okay, we have different chapters across India, like 45 plus chapters in India, with headquarter at CSR CFTRA Mysuru. And here we represent the Mumbai chapter. Very quickly, we liaise between the industry, academia, regulatory, students, all put together, and we do a lot of such interesting sessions with the students. Okay, this is very quickly about. Can you please everyone keep on mute? Yeah, thank you. Great. So very quickly about the CSMB, who are the partner for the event. The CMB is a chamber for advancement of small and medium businesses. They're working on extensively on the advancement of growth of the micro, small, and medium businesses. They support academic research, advanced technology, government schemes, policies, benefit to all SMEs. Right? They help in capacity building through training and development. And they do many more things, but what we're focusing here is training and development, which is my key for here to understand. And we support all the students, academia, and passing the knowledge to the students. Okay, that we do. And in today's session, we'll talking about the food factories. And here, like my pleasure to introduce about our today's speaker, Mr. Sagar Kurade. Very quick update on Sagar's profile. Sagar is CMD for the company called Suman Project Consultants, and he has a 25 years of experience in food processing sectors and have worked in India's leading industrial consulting company in agri infrastructure, food processing, and they've set more than 500 plants across India and abroad, right? And they support various project planning, project implementation, regulatory advisory, including market tie-ups and even merger and acquisition. They've been supporting that. Saga is always the forefront of any of the factory, any of the food factory, especially when it comes in picture. And they have said that then they're recognized by national international awards. A few of them is NCCI awards on food processing, NCR by Chambers of Commerce and Ministry Industry, Udyog Ratan Award by Institute of Economics Studies, IC awards for dynamic leadership. So he has like various awards in his portfolio, and they do very large scale projects of food factory setup. Like Sagar is an food science graduate, and he's also like done his MBA from Ministry of Hartford, Connecticut, USA. With that very short profile about the Sagar, I will request Sagar to start today's session. So Sagar, over to you. We want to hear from you about how the food factories are set up. And people have a lot of questions on such mega scale food factory, how they're set up. We always see like in Discovery and similar channels how those happen, but we want to hear from you how you do this and how you make magic to the food industry. So over to you, Sagar, and I request IT team to give the access of the presentation or sharing a screen to Sagar.
Thank you so much, Ritesh. I'll be waiting for the screen share access to come through. And I appreciate your good words. And I'm happy to be sharing our thoughts on today's topic, which is the what and how of setting up a food processing plant. You guys see my screen?
Yes, we can see screen, Sagar. We can see now.
Request the participants to mute, please. Thank you, Ritesh. Thank you, Ritesh. Thank you for allowing me the opportunity, and thank you to AFST team as well as CASMB to give us this opportunity of sharing from our experience the what and how of designing a food factory. So to give you a perspective, this is a little bit about us. We are a 53-year-old industrial consulting company within the food processing space. We have set up more than 650 plant and projects within the food processing sector. As Suman Food Consultants, we provide complete hand-holding to our clients from planning till commissioning of all areas within the food processing space. We have pretty much who's who of the food world as our clients. But more importantly, a majority of our clients fall under the MSME side and medium and small scale enterprise side. And many of them have gone on to become large companies or big companies, national brands in India. If you want to look us up, you can look us up at sumanfoodconsultants.com. To take the topic forward today, when it comes to designing and looking at a food processing plant, there are two major factors that come into play. One is the external factors. The external factors are primarily those in which while we are planning a plant and project, do not have much control over. And therefore, those are the factors we have to account for when we are undertaking planning and designing of the food processing plant. The internal factors are the one on which we have a control, but have to look into it in details in order to ensure that the factory is planned and installed and commissioned in accordance to those expectations that are there. My today's topic is going to be talking on each and every of those factors, so that there is a deep understanding in terms of what needs to be looked at when we are looking at putting a food processing plant in place for our clients. So let's talk from an external factor point of view. When it comes to external factors, location plays a key aspect in planning of a food processing plant. Now, why location? Primarily because of the availability of raw material. If you have to understand, in terms of food industry, we are a big country where there's a lot of diversity in terms of the horticulture profile. Typically, food industry is put in an area where there is a good availability of key raw materials within about 100 to 150 kilometer range of the food processing plant. So that becomes a key factor in terms of planning a plant. The location, as I said, has an impact with regard to the raw material availability. Another factor of location which we have to look at is from a point of view of climatic conditions. So different, if you are in a heavy rain zone area, the plant has to be designed differently. If you are in a very dry area or a hot or a humid condition, there are different aspects of plants that have to be looked at. Water is a key factor when it comes to plant. There are areas you have to keep in mind where borewell is not allowed, and you have to therefore look at water availability from a point of view of sourcing it from either the municipal availability or from natural source conditions as per a mandate given.
क्या कर रहे तुम लोग गर्म हो वो जमीन में घूमते रहते हो
So as far as power is concerned, power is another factor. So you have to keep in mind that power is a state regulated issue. So what happens is the cost of power in one state is going to be different from the cost of power in another state. And therefore, entrepreneurs make a call on the location of a plant based upon the power availability also from a point of view of the fact. I'll give you an example. For example, Uttarakhand is one of the states which has a very low power cost, unit cost to power as compared to, say, Madhya Pradesh or as compared to Maharashtra. So if I'm looking to set up a very power heavy kind of a plant, and my raw material availability is there in that particular region, I may, and it is there also in Maharashtra, I may look to set it up in Uttarakhand versus Maharashtra because of the power factor associated with it, because in terms of running, it will be much cheaper. Obviously, we do projects in India and abroad, and hence the safety and security aspect of a project also comes into play. I will give you an example. For example, Angola, where we have set up plants also, or some African countries, but let's take Angola as an example. Till 2003 was under a civil war. And in 2003, Angola opened up. And therefore, as the country opened up, a lot of security and safety factors that were a concern area, those got removed. And therefore, you had a lot of plants and projects that came up in that particular country. So, raw material availability, climatic conditions, water availability, power availability, and security and safety are some of the key factors when it comes to locating your food processing plant. More importantly, there are also factors these days with regard to the incentives. Like there are government of both state governments of various states as well as central governments gives incentives both in terms of capital subsidy as well as in terms of running subsidies that are there for setting up a food processing plant. Now, you have to keep in mind that in a country like India, the subsidy is different for different states. So each state gives different subsidies within the food processing space. And that may vary from, say, 5 crores, for example, in Uttarakhand, which Uttarakhand gives, or for example, Andhra Pradesh gives, and to 50 lakhs, which a Punjab state government may give. So in case the subsidy is less, the entrepreneur may also look to set up a plant based upon a central government subsidy. So friends, location is one of the key factors that has to be looked at from a point of view of food processing plant. Let's look at from a point of view of land. Because land is a factor that is key from a point of view of what kind of infrastructure on that particular land can come up. So when we are looking at planning and setting up of a food processing plant, the soil quality is an important aspect of it, because the weight of the entire plant is and the foundations on which it has been put will depend upon the quality of the soil. So initially, when we are in a stage where the structure has not been put and we just have a land, there are soil quality testings through drilling of holes in different locations of the plot that we do, and the quality is typically tested. Then importantly, we also have to look at the topography of a particular plant. So for example, if we are designing a plant, let's assume we are designing it in Sikkim or in a northeastern state like Assam, which will be much more hilly, versus in plain land like Uttar Pradesh or in Madhya Pradesh. We have to look into the topography factor. Sometimes a land may look flat, but there may be certain contours which one has to account for. So that is also important. Also, you have to understand that the governments, especially state governments, allow certain plants in certain zones. For example, if I'm looking to put a meat processing plant, the meat processing plant would come into a polluted zone area. Okay, it will be a red zone or an orange zone, depending upon how the state defines it. And if I am putting, let's say, a project which is not so polluting.
बस कपड़े काट and कपड़े धोल देते हैं.
Excuse me. Yeah, so that may come in a green area associated with it. In addition to that, one has to look at also the water levels. Now, water level is not necessarily from a point of view of the source of water, but it is also from a point of view of the water coming into the foundations. Foundation of a plant has to be designed from a point of view of how high the water comes up. Now, you have to keep in mind that this water level keeps on changing. So you have to understand that we have to look into a kind of worst case scenario. For example, when it is the rainy season, that is the season in which we have to look at it from a point of view of water availability and its peak, the highest level it reaches. And it should not, suppose you have a basement level, it should not, the water should not come and reach your walls into your basement, which can be disastrous for a plant. When it comes to land, one has to also understand that land area is an important aspect that we have to look at. So different people go with different aspects. So sometimes there is land availability, so it can be a single structure plant. But in areas where there is a limitation of land, we have to plan it in multi-storied structure. And in multi-storied structure, therefore, the designing of the plant will be very different. And the foundations on which it gets built will also be very different as compared to a single-story structure. We will be coming on those specific areas as we move forward into the internal. But one of the key factors sometimes in land where we do not have a control over is when a client typically says that there are some Vastu factors that have to be kept in mind. Now, for example, when it comes to Vastu factors, when we are planning a plant, the client may say heavy machinery is on the northwestern side, or on the southern side, some electricals and boilers to be kept in mind. Those can be looked at. So those are factors we have to kind of look at. I'll give you some examples in terms of contour that I talked about. So contour mapping is typically done by a party, by a third party, but importantly, it gives us an indication of how high within a plot different surfaces are from a sea level point of view. And it gives that aspect associated with it while planning. And when we are looking at Vastu factors, this is a perspective with regard to north, east, west, and south. So typically certain areas are expected in west side, certain areas are expected in east side. And let me tell you, not every entrepreneur or a company typically looks at it, but there are sometimes expectations which have to be planned on in accordance to the setting up of the plant. So, let's talk it from a point of view of raw material, which is which primarily raw material is an aspect that needs to be looked at from a point of view of quantum expectations. Okay, which means that it's not about availability of the raw material, but it's also about the quality of raw material and the quantum of raw material available. So I'll give you an example. Let's assume you want to set up a onion garlic dehydration plant, all right? And you want to set up onion garlic dehydration plant in and around National Capital Region of Delhi, or let me just say parts of Maharashtra. Okay, I can assure you, whatever capacity of plant that you may decide upon, that project is going to fail. Okay, the reason why that project is going to fail is because of the quality of the raw material available. So while, say, parts of Maharashtra may have white onion availability, red onion availability, there is hardly any availability of white onion, which is the major market with regard to the dehydrated onions. So it is not about onion availability, it's also about the variety that is available. Again, another example of that is we have more than 500 varieties of mangoes. Okay, but not every variety of mango in terms of pulp or concentrate is marketable. Primarily, the varieties that get marketable from an India perspective are Totapuri, Alfonso, and Kesar. And the regions associated with this are different. So you cannot look to put up a pulp and concentrate plant, let's say in Bihar, and say that, all right, I want to process Totapuri and Alfonso. Let me tell you, you may be able to set it up, but in terms of viability, that will be a serious concern in terms of the plant surviving for more than a certain time period. Also, another factor that comes to with regard to raw material is a seasonality factor. So keep in mind that when we are looking to plan the plant, we also have to plan the raw material in such a way that the plant is operational throughout the year, almost throughout the year. So the idea is that the plant should be operational for at least 300 days in a year, so that the viability or expectations with regard to the plant can be met up as much as possible. Keep in mind the distance of the raw material availability is a key aspect with regard to the location of the plant. So do not when we are working with our clients, ideally plants should not be more than 150 kilometer radius from the raw material source, which we definitely look at. But there are certain exceptions. This is not a ground rule. For example, if I'm putting, if I have to process, let's say, cardamom, all right, cardamom need not necessarily be processed in southern belts where it is mostly available. I can look to process in mid states also, primarily because my cost of transportation, because of the value of the raw material, is not going to be so high as compared to, let's assume, if I'm taking a chili from a certain state, or if I'm taking a turmeric from a certain state. So, so raw material plays a factor in terms of plant expectations. Let's look at it from a point of view of manpower. Now, manpower is another factor which an entrepreneur typically looks at, and that defines the automation that is coming into the plant. So obviously, the availability and cost of a manpower varies from state to state. In fact, keep in mind that each state has a minimum wage factor defined. Some state may say, all right, manpower needs to be paid 450 rupees a day. Some states may say minimum wage is 550 rupees a day. It varies from state to state. But what is important and critical is when you're looking at manpower, depending upon the size of the plot, sometimes the worker availability is not there, and it may be in a remote area, because of which workers' residences may need to be planned in the proximity of or within the plot area of that particular plant. And if workers are residing or when workers are working, sometimes dining facilities are also required to be planned on, because there are breaks and then there are shifts, and workers. It's important to ensure that in order to have an efficiency built into the plant, and especially in remote areas, the workers' residence and the dining facilities are important aspect in terms of planning of this plant. Let's look at it also from another external factor, which typically is not in our hands, that is with regard to road connectivity. So keep in mind that transport cost plays a very important role in terms of a success of that particular plant. So I just wanted to share this industrial location infrastructure that is there. If you guys can see, these are agro-based industries across different parts of India. Now, you will typically find that you see there are gap areas here. Let's assume between Varanasi in UP to Calcutta, or Varanasi to Cuttack, or Varanasi to Indore. Now, keep in mind that the purpose of sharing that perspective is to kind of reflect on the fact that typically it has been seen that if the distance between two major cities is more than 400 odd kilometers, the industrial activities typically in between the two places go down. Okay, so if the road is not well connected, or there is not good connectivity between two major cities, and especially if it is 400 kilometers or beyond, the industrial zones get reduced in between that particular area. Thankfully, in over the last 8-10 years, we have seen a good infrastructure getting built up, and the connectivity, at least between the two major cities, has improved. What we now need to also focus on is probably more cities coming up in India that takes care of the population aspect and the boom associated in our country. But that's a totally separate topic, which requires a totally different discussion. So connectivity is important also from a point of view of access to market. Now, keep in mind that in case there are certain products that require export, sometimes a client prefers the location of the plant to be closer to the ports. We recently had an issue with regard to ethylene oxide and ETO treatment of spices, where we found Singapore and Hong Kong government taking some actions on some of our Indian brands. But keep in mind that there are multiple ways in which you can look to export. One of the ways in which you can look to export, say to countries like US or some Western countries, is through irradiation. So you look at product and you irradiate that particular product through cobalt-60 exposure. And those are the regulatory expectations of the country if you are looking of that importing country, if you're looking to export it from India. So those irradiation infrastructure may not be in your city. They may be there in Bombay or some ports of Gujarat or some ports. So you have to look at it from a point of view of location of your plant, depending upon your access to that particular market also. So keep that in mind. Another factor I just want to throw out here in terms of transport is sometimes, refrigerated connectivity is not so good in some of our areas of the country. So, for example, if I need to send a frozen food product from, say, parts of UP to parts of Uttarakhand, or a plant in Uttarakhand needs to send it to another plant, the refer facilities are in UP, not in Uttarakhand. So they may have to charge you double the cost of going from their location to your plant, and from your plant to whatever destination they want to deliver it. So those are also sometimes the factors that have to be looked at when we look at the plant aspect associated with it. So those were factors that are not actually in our hands when we are looking at it from a point of view of plant, but those are factors that have to be looked in, whether it is road connectivity, manpower, raw material, land expectations, location expectations, etc. So having said that, let's look at some of the internal factors that play a critical role in terms of planning and designing of the food processing plant. So when we are looking to set up a building and an infrastructure, depending upon what kind of food product we need, or depending upon client's cost expectations, we have to plan on the structure. Now, that structure of a plant can be a civil structure, which is more from a point of view of bricks and cements, pure bricks and cement kind of a structure, to a pre-engineered building. So there are companies that supply pre-engineered material also. But if you have seen plants where there are metallic sheets that are there, which typically are built over and above a civil structure. Now, keep in mind the cost factor. So I'm just going to show this example. If you see this picture below, the roof that has been put up there is a pre-engineered roof. Okay. Now, this is important from a point of view of also achieving a certain cost expectations. So typically it has been observed by us that the cost associated with a pre-engineered building is less as compared to a civil structure. But there is sometimes need for putting a civil structure in place. And sometimes if you have an alternative where the cost can be brought down, we look to put a pre-engineered building associated with it. Now, when we are looking at a building infrastructure, you have to also ensure that certain parameters are also important aspect with regard to the plant. So when we are planning a plant, the height at which the height aspect of the plant in which machineries get placed are important. And also the floor aspect. The height aspect I will talk when we are looking at the plant and machinery side of the slide. But the floor aspect, there is multiple options today the entrepreneur has. You have to understand that for a hygienic operations of a food plant, it is important that the floors of the plant is well cleaned and maintained. And therefore, so that there are no cracks and everything, sometimes clients look to put epoxy flooring, which you are seeing in below in this example. Sometimes if the client has a little bit more budget, you may look at PU flooring also. And otherwise, there are tiles which are densified tiles, flooring, or otherwise that one can look at from a point of view of the plant. So that in case of any heavy machinery on it or any acidic or chemical falling, there should be no reactions in terms of flow and no cracks that get generated. Also, when we are looking at it from a point of view of plant and infrastructure, the electrical plumbing distribution is another important aspect that needs to be looked at, because the plant, the distribution requires to be done at different areas of the plant. Specifics we are also going to be discussing in our other slides. From a point of view of putting a plant, process and technology is an important aspect associated with putting a plant, and students of food technology here on this platform today will appreciate that, because you cannot put a food processing plant without understanding the process expectations associated with that particular plant. Why do we need that? Because process and technology helps in defining the various area allocations that come within the food processing plant. So you cannot do a copy and paste of one food plant versus another food plant, because the expectations in terms of process will be different. I'll give you an example. Let's say I am putting a spice processing plant. Now, in spice processing plant, I just don't need to only put a cleaning and a grading section. I also need to have a section associated with cleaned area, where cleaned area raw material is put. Or you may look to also put it from a point of view of cold storages as required. What is important here is the material movement should not be hindered in terms of. So when we are looking to kind of take that plant and project, we need to ensure that that plant and project has a certain uniform flow to that whole plant in terms of material. I will talk about it in another slide coming up. Okay, but process and technology has to be looked into when we're looking at it from a point of view of designing a food particular plant. When we are looking at, once you have looked at the process and technology, obviously, therefore, the next aspect that comes into play is what kind of machineries are going to be coming up in that particular food plant. Now, why do we need to do that? We need to do that because each machinery not only helps the client in terms of manufacturing, but in terms of food plant planning, they have certain weights and heights associated with also. So, for example, if my machinery, which is let's say it's a 2 metric ton machinery, all right, that's coming up on a first floor of a particular food processing plant, my first floor slab has to take the weight of that entire machinery along with all the machineries that are typically coming up on that particular slab. So when we are looking to put a food plant, it becomes very important to understand the weight expectations of different machineries across different floors or across different areas of that particular plant. Again, the height matters because each machinery has a certain height implications. So to give you expectation, give you a perspective. Let's say I have a plant that requires packaging in form field seal way or in a pick field seal way. So the packaging expectation, the height expectation would be about, say, 12 odd feet, which means we need about 14 odd feet to ensure that that packaging machine can fit into that particular location of that particular plant. But if the height of that plant is at 10 feet, it becomes very difficult. Other than the fact that we then have to look at breaking the slab and seeing if we can take it into expose it to another floor above it or not. So plant and machinery has an important factor, and keep in mind, while we will be talking on it more, plant and machinery also has an impact on the utility. So plant and machinery defines what kind of power you require for the plant, what kind of water you require for the plant, what kind of compressed air you require for the plant. Specifics we will be talking about as we go along. So let's talk from a point of view of plant layout. Now, keep in mind, if you see, I'll just go into this slide and try to expand and see if you guys can see it. Okay, so keep in mind, let's take this slide only that is there. When we are looking to put a plant layout in place, it is very important that there is a uniform flow of that particular material movement. So a plant, when we are looking to design a food plant, cannot have areas where material is coming back and forth. Once material has left the raw material section, it cannot be coming back into the raw material area. Okay. So that is why it becomes very important to plan the layout in such a way that the material movement is a uniflow movement and not impeding different sections of the plant. This also, therefore, ensures an efficient plant operations and also ensures efficient space utilization that comes into play within the food processing plant. Strategically, equipments are placed in such a way that once, let's assume we process a raw material, for example, and it goes into finished goods, the material cannot come back into the process section or into any other sections. From that, it is to be dispatched. And within the process area, the positioning of your spare part room, the positioning of your packaging material room, the positioning of lab has to be placed so that there are checks and balances and easy material with regard to expectations of different sections as being planned within a food plant. Plant capacity is one of the key factors that come in terms of planning a particular plant. Now, why plant capacity? Primarily because we have to define the area expectations that come in terms of capacity. So, for example, let's assume a 2 metric ton plant would be planned in terms of area allocation in a much smaller way versus a 10 metric tons plant. When I'm saying 10 metric tons per day or 10 metric tons per hour, whatever you want to look at from that point of view. So it defines the quantum of raw material or finished goods that will be required from point. And we have to look into how much is that quantum, how the material is going to get stacked, how the material is going to be put, whether it's finished goods or raw materials or packaging or whatever be the case. Okay, so plant capacity also defines the machinery expectations of the plant. So, for example, a certain rated, suppose I am looking at, let's assume, an IQF plant. Okay, so if I'm putting a frozen fruits or vegetable plant today, I cannot be looking at it from less than 20 metric tons per day capacity, because less than that is going to be totally unviable. Okay, when I'm talking about frozen fruits and vegetable point of view. Now, if I'm looking at it from a spiral freezer or I'm looking from a blast freezer, the capacities therefore become different associated with it. The capacities also therefore define the automation that is going to be going into the plant. So sometimes the plant is put in such a way that we have to do it in continuous but in a batch way. I'll give you an example. For example, if I'm putting a continuous plant of a ready-to-eat, let's say I'm making biryani and I'm making biryani at say 400 kgs an hour, okay, or 500 kgs an hour in terms of production. But I have in terms to make it shelf life stable, I have to have a retort. Now, retort is a batch process. Retort is not going to be a continuous process. So while I am doing retort, I will have a continuous flow of raw material product coming in as packed into my retort section. And therefore, my retort section has to be planned in such a way that that also is going to have a continuous operation going in, and I don't have a product lying in associated with it. Plant capacity therefore becomes critical from a point of view of planning the food processing plant. Now, some things that typically people ignore is with regard to the lighting and ventilation when it comes to food processing plant. Now, keep in mind that there are regulatory implications with regard to what kind of lux factors are required in a food processing plant. You just cannot put a light and say that it's bright enough. That bright enough is determined by the lux factor that is there. There's a measuring equipment that also gives you that lux factor associated with that. Now, typically when a food processing plant is put, the range of raw material, process, finished goods areas comes into the bright range. So the lux factor typically vary from 400 to 600 in terms of how the lighting is placed, and there should be no gap areas associated with it. It should be well lit across all areas and all corners of that lux factor should play into account for all corners of the plant, not just in a certain area within a certain section. Same thing is in terms of ventilation. So when we are looking to plan, I mean, we are all facing heat at this time of the year, Imagine, I mean, we have a situation where temperatures are reaching 50 degrees, and you have conditions in a plant where cooking is happening, steam is there, heat is getting generated, and the workers therefore not only have to deal with the outside heat, in addition the heat within the plant. Those working conditions become unbearable and not possible for any worker to operate efficiently. So the entrepreneurs typically take our help in also planning the ventilation systems associated with the plant, which therefore requires to be looked into to ensure a good working conditions associated. They can be within 25 to 35 degree centigrade in terms of a range. And the air circulations will also vary depending upon what is the size and capacity of that particular plant. Uh, there are certain areas which require a certain temperature control also. So, for example, I have a prepared frozen food. I have made my biryani. I have done, say, blast freezing to it, and now I have to pack. Now, that packing cannot be happening in of a frozen product in a totally 35 degree or 30 degree centigrade. You have to ensure that the packing is also happening in certain conditions, which are chilled conditions, comfortable enough for the workers, so that the product is also not impacted in terms of quality, and the workers are not so also impacted from a point of view of working conditions. So lighting and ventilations are very, very important. One factor I like to share is there are times in which we can look to save our cost also in terms of lighting. Sometimes when we plan a plant, we put skylights on the plant in such a way that minimum amount of lights therefore has to be used at least during the daytime. And that also helps in terms of saving of them. This is typically true for a pre-engineered building versus a engineered building that typically comes into place. I know we are falling short of time, but I want to kind of share a few slides that are there also that are important from a point of view of planning a plant. So when we are looking to plan a plant, it's important to ensure that there is a proper drainage system that is there, both within the process area and outside the plant also. So within the process area, suppose the plant has a wet operations in place. It's a beverage plant, or it requires regular cleaning. Let's assume the plant involves processing high protein product. Let's assume meat products or milk products or something like that. We have to ensure that there's a proper cleaning, and proper cleaning of the floors involves proper drainage being put into place. Now, in that drainage, it's very important to ensure that there is no rust, there is no collection of any dirt, and there is not only on top, but also within the drain. And when you're planning it, it becomes very important to ensure that the drains are also easily maintainable. It's not just about putting the drain, but in a plant, within the plant, we also try to ensure that the drains are maintainable. Therefore, the covers on top should be removable, and proper maintenance can also take place for regard to the drains associated. These are important sanitary conditions and hygienic conditions that require to be put up. Keep in mind that typically around the plant or nearby plant, depending upon what's the size and scale of the plant, there are drains, and the regulatory standards typically define that we can put our effluents through a drain only through a certain treatment, which we will also talk about in our upcoming slide. But the connectivity to drainage and the drainage within the plant also become an important factor in ensuring that proper hygienic conditions and regulatory standards are typically met within the food processing plant. We talked from a point of view of machinery, and we also talked briefly that machineries have an impact. on utilities. Now, those utilities have to be also looked at within a food plant, because keep in mind that my machinery requires power, and I cannot look to therefore put power line expectations like we do in a concealed way in a residential area or in a residential building. Those have to be planned in such a way that they are easily maintainable. So in a plant, in a food plant, when we are looking to kind of put different pipings or different structure, we need to put it in such a way that in case of any issues, they are easily maintainable. And that's an important expectation. So the electrical wiring, electrical cabling that typically happens under open channel conditions. The channels typically run through in different sections of the plant, and the power connectivity is typically given to those plant and machineries. When it talks about water, water is a very, very important factor from a point of view of ensuring. Now, the kind of water treatment plant that typically comes, the WTP that comes in the plant, that depends upon the water quality that is available. That can be a municipal water also, that can be groundwater also. But keep in mind that we cannot take the water, no matter what the assurance from anybody, directly into plant without treating it. Now, that can be treated with a simple softener, that can be treated with an RO system. That depends upon the quality of water that typically is available. Also, equipments, your treatment plants, water treatment plants, effluent treatment plants, your packaging machinery, they all require compressed air associated. And we therefore have to plan on the line and expectations of ensuring how the compressed air typically reaches that particular section of the plant also. These are different sections that we need to plan from a single compressor, but that compressor has to be planned in such a way that single compressor is able to provide expectation at a certain bar pressure to different equipments and machineries. This also is true for steam. So if for example, my boiler is giving, I require a boiler for cooking, but my boiler is giving me at 10.5 bar pressure in terms of steam, and my equipment and machinery is requiring steam at say 3 bar pressure or 4 bar pressure. I have to ensure that there is a PRS system, a pressure reducing system, that typically goes and is put in accordance, and my steam utilization is such where I'm able to put a plant where the steam typically has a condensate return facility, and that condensate helps in my lesser usage of briquettes or anything required from a point of view of fuel. That also helps in making the plant environmentally friendly. There are a lot of factors that go into making a plant operationally efficient, and these are some of the factors that we have to look at to not only put a plant but also ensure the operational efficiencies of that particular plant. Just giving you a perspective, like, so if you are looking to put a fire or a gas, let's assume an LPG expectation is there. If the area gives us an LPG directly, we can take it. But typically, we have seen that there are certain areas that are outside the plant that have to be created with a certain fencing so that it doesn't damage or impact the plant in terms of any fire hazard related issues. Those have to be planned also. For example, if we are also planning, let's say, a CO2 expectation or hexane requirements in a solvent extraction plant. So we cannot take hexane and put it inside the plant. There has to be planned outside the plant, and those solvents have to be kept in such a way that fire safety precautions and measures are kept and put in place associated with it. Even in terms of wastewater treatment, there are two technologies that typically come into play. One is MBR, another is MBBR. That depends upon the kind of effluent that typically are there in the food plants associated. So just an example of various utility factors that are important to be looked at when we are looking at it from a point of view of designing and putting a food plant in place. Let's look at it from also from a man and material movement associated with the plant. So let's talk from. Let me give you an example here. This is an example we are sharing with you of a workers' access. So when we are looking at it from a point of view of setting up a plant, it's important that if nobody should be able to enter the plant from any given particular area. It's important that the access to within the process area is planned in such a way that workers are coming in and going out in an orderly way and not from anywhere there. Of course, the plant requires fire escapes to be planned and everything. But in terms of access to the plant for workers, for ladies workers, it typically is different. For gents workers, typically different, but they have to be planned associated. And even management, sometimes management may not take their visitors or clients from general areas. They may want to access it from different areas, but their access has to be planned in a way in which it is hygienic. It does not impact the aspects. So you need to ensure a proper dress code going into a process area. You need to ensure a proper access and hygiene parameters are followed in that area. Even when we are looking at planning, it becomes important to ensure that how many workers. So when we are planning a plant, one of the things that we look at is the manpower expectations, and manpower expectation therefore has an expectation in terms of the cycle areas, the bike areas, the car areas, the outside factors coming into of a plant that are typically defined. We allocate our areas, as you may see, differently for cycles, bikes, scooters, so forth. There are way bridges in case you have a large plot area typically, and you have a huge quantity coming into the plant on an hourly basis. Way bridges are typically planned. Now, way bridges can be planned within the plant or can be planned outside of the plant also. That can be a third party thing also, or say in a food park. The food park would have their own way bridges. But in addition to that being a common facility within a food park, how that helps is to ensure that the truck is weighed before the raw material comes in, and truck is weighed as the raw material is unloaded and goes out. And the same is repeated when it comes to finished goods also. That way, the net weight of product coming into a plant and going out of the plant is calculated and can be checked with different balances in place. When these trucks come in, the receiving and the dispatch area have to be planned in such a way that they are not leading to much of a traffic jam. Sometimes we have seen, if you see sometimes, it's outside of sugarcane factories, some of them, there's a huge line of trucks that are there. Now that whole plant may have been planned with only a limited receiving or a dispatch area being planned. Also, sometimes when you have a commodity which has a seasonality effect, where in a particular season a huge quantum comes, you have to ensure that the loading, unloading of that particular raw material or a dispatch during, say, Diwali season of finished products or festive seasons is taking place in a smooth and orderly way. So dockyards are typically planned. Sometimes dockyards are required. Sometimes we have to raise the plant up to a certain height so that truck material going into the truck is at the same level as that of the dispatch area of the plant. So that also becomes an important aspect for planning. These were examples. I mean, I'm going to give this example from a point of view of, if you see here, the worker access areas is there. It's separate for ladies and separate for gents that are there. We have material, we have manpower coming into the plant. The ladies are going into their section. The gents would be going into their section. Changing rooms, lockers, and everything are provided, and then they are going into the plant site associated. Also here you would find an example of a weighbridge, which can be planned in different ways that are there. It can be at the same as road level, or it can be above the road level also, depending upon how it is planned. The regulations and compliances are important from a point of view of planning a plant. So, for example, as I mentioned earlier, if I am looking, if I have effluents in my plant, and most of the food plants do have effluents happening, even if you are doing nothing from a point of view of throwing water, but just cleaning floors. Okay, even if there is a wet cleaning of floor happening, those effluents cannot be simply drained out as such. You have to treat them, whether it is, and you have to treat them in such a way that regulatory parameters are met before they are dispatched. Now, typically what we do today is we do what we call a zero liquid discharge. Zero liquid discharge involves when sewer water that comes into the plant, that water is used as much as possible within the plant, and any wastages that come from that water are treated through effluent in such a way that we can reuse the water again. So whether we typically ensure that any effluent coming from water treatment plant is reused back in toilets or non-contact parts associated with the food processing plant. Similarly, when it comes to treated water, as I mentioned, you cannot take any water and use it in your process related to contact food. You have to treat them and and process it. One of the key aspects that typically also come into fact is compliance aspect. Is sometimes a client is in a rush. Client wants to make sure that the project is done to meet certain market expectation in a short time period. But then it's important to do that in a practical manner also. Therefore, anything related to scheduling or hand holding in terms of a timetable to be put, we also help in defining that associated with it. Licensing, as you know, is important. You cannot look to make or produce a food processing plant without having an FSSAI license. But why I am bringing the regulations into account right now in planning stage is because you cannot look to make changes tomorrow when you are going for a BRC certification or say ISO 22000 certifications. Changing plant layout or changing infrastructure at that stage becomes a very difficult issue versus doing it now. The best time to do the project, to adhere to future certification expectation, is to ensure that the plant is planned in such a way that your future expectations can be met for that particular plant. I'm just going to give you a small example of a previous plant, previous slide I had shown. If you see this plant, the green flooring that is there, in these corners that are there, in these corners, you cannot have a sharp 90-degree corners. There have to be covings that are there that give no dust collection or dirt collection that typically takes place in a certain plant. Small little minute factors but they play an important factor in planning of that particular plant. So when it comes to planning, hygiene and sanitation are a key factor. So a lot I've seen sometimes entrepreneurs do not give a focus to the call to the laboratory equipment. Now, lab equipments become very important and critical because they help you to define your critical control points of that entire plant. So when we are the expected output quality of your finished product is only going to be as good as the inputs that are taken into account and the process that is going to be followed. And how do we know that process is followed? How do we know that input quality is good? Is by testing through different parameters through lab equipments, the quality standards. So the critical points are typically defined to ensure the quality expectations of that plant. Keep in mind that when we are planning a plant, the pest management, and I'm not just talking pest management from a point of view of rodents, but I'm also talking from a point of view of fly traps or flies coming into the plant. So sometimes in dockyards, if you see when we are putting a plant in place, we put air curtains around in the entry or exit of different areas. That is primarily put so that when doors are open, when plant is open, you do not have flies or any insects coming into the plant from outside, and they work on an automated way connected. You have to ensure that personal hygiene I showed you regarding the plant access, but it's also ensuring that the personal hygiene is followed in that particular plant. Your hair is covered, employees wash their hands. There is the plant, and to wash their hands, you require certain wash areas that are to be planned for the workers. So that also becomes an important factor. If workers' clothes and caps or gloves are given, you need proper disposal aspect associated with. Also, you need to ensure that the clothes are also disposed in a way where it can be dry cleaned and brought back to the plant once washed. So those are aspects related to sanitation and hygiene that become important. Uh, uh, this is not only to ensure a better quality assurance with regard to the product and process, but to also ensure the health and safety of workers that are there within the plant. So you need to ensure that there are designated areas that reflect the process flow, the repetition of rules that are to be followed, so that it is not a one time in terms of training, but it's easy to read for workers on a regular day basis and keep it in mind for them. My last slide is going to be more from a point of view of green initiatives. So these days, there is a lot of awareness with regard to the greening initiatives. We have done a project for National Meat and Poultry Processing Board also with regard to how to bring the cost factors down in a food plant, which looks through green initiatives. So, and even today, when subsidy is being allocated, sometimes uh, the government may be looking at it from a point of view of what green initiatives have been taken within the food plant. So, solar panels have to be planned and provisioned that helps in carbon dioxide reduction and also utility reduction. But keep in mind that keeping the plant 100% solar powered may not be also possible, but practically one has to do whatever little or more they can to ensure a better environment for the plant and to the future generations also. We talked about zero liquid discharge. Now, zero liquid discharge is planned in such a way so that whatever water is coming into the plant is best utilized, and whatever are the effluents that are going out of the plant, rather than going out of the plant, are utilized within the plant by treating and processing them. Therefore, your water quantity requirement also goes down, and you are adhering to the environment also. Also, some of the plants require scrap yards to be maintained. Those scrap yards have to be put outside the plant, not within the process areas. That has to be managed. For example, tea or plastics that are there. Sometimes we need to ensure that scraps are put in an outside designated way associated. And more importantly, all these plants should lead to zero emission initiatives, which are also helpful when you are looking at environmental certifications. So whether your plant has zero emissions or not, but as long as you have taken certain provisions and tried to have those incorporated as green initiatives, those are looked in a positive way tomorrow for any certifications also that you may be looking to put in place. So with that, I like to thank all those who have attended today and heard our experience and perspective with regard to food processing plant. I do open and request the organizers, we are open to have any questions in case anybody has, and we would be happy to kind of take it. For anybody who wants to contact us, you can look us up at sumanfoodconsultants.com, or our email ID is also given on the screen. Thank you so much, and we look forward to anybody having any questions on our presentation today, or anything in general that they may have with regard to food plant. Thank you so much.
Sagar sir, thank you indeed for such a wonderful presentation. I think most of the questions that have come in, you've already answered them through your presentation. Thank you so much. We still have a couple of questions that I would like to ask. With the increasing rise in AI and automation, many of them aim to integrate such automation or AI into their food factories in order to have a more smoother supply chain management. So, what is your opinion on that, and how can that be integrated in designing a food factory?
Yeah, so AI is the way forward. I mean, if you see the natural progress of the industrialization, we had an industrial revolution, then we had an electronic revolution, then we had an IT revolution, then we went into robotic side, and now robotics is going into AI side. So it's a natural progression that's typically happening associated. Now, there are two aspects that typically play a factor. Robotics is already getting used in terms of many warehouse applications that are there when it comes to first in, first out associated, or in terms of warehouse space utilization. The larger the scale, the more the automation typically is required in a particular plant. So both in terms of production, in terms of maintenance of a plant, AI aspects is already being looked at, and also from a point of view of customer service when it comes to marketing a particular product. There also customer service handling and intelligence is looked at from an AI point of view. So these are important aspects that have to be considered when we are looking at it from a management and maintenance of a food processing plant. But keep in mind that in India, there has to be certain practicalities also. The practicalities are the scales of and sizes of food plant may not be high, and which means that you don't want automation to an extent where your plant in itself becomes unviable. Okay, so there is a cost to automation also. So keep in mind that we may be the fourth largest economy in the world, but still our per capita income is $2,500. So the average person in India can only buy so much, and therefore there's a price sensitivity to the food products you are offering out there. While you can sell a Maruti and a Mercedes both in an economy, but you have to ensure that if you want volumes, then you need to be a little practical in terms of automation also taking place in a food processing plant. Yeah, please go ahead.
Yes, thank you, sir. Another question is, sir, if there are two more important factors that are to be taken into consideration while planning a factory, and both of them are being compromised at a point, how is a choice made? For example, if we have to choose between power availability and water availability, how to decide what should be given a priority?
I think both are a priority, right? I mean, if the plant requires water and there is no water availability, then you can't have the plant at that particular location. Power has an option in the sense that you can ideally, sometimes what happens is, so it's not about just putting a plant, right? It's also about managing the plant. So every entrepreneur likes to put a plant based upon their strengths. So they don't want to travel 4 hours away every day to a plant and come back 4 hours to manage it. It's impossible. Person gets burnt out very easily. So you have to ensure that when we are doing a viability of a particular plant, the water expectation is defined, the power expectations are defined, and it is also therefore the cost aspect associated with both have to be looked at. You cannot look at these 2 points in isolation. This also brings to an important factor that when we are looking to put a plant in place, there is no one factor that only comes in play. A plant is an integration of many factors that make it successful. So you can't just look at it, oh, all right, I have a lot of tomato availability in my district, so let me put a tomato processing plant. Those tomatoes may not be even processable from giving you a good input output ratios. So plant, raw material, power, water, all have to be looked into when we are planning a food plant.
Thank you for that perspective, sir. One last question. Want to know the potential use of blockchain technology in a food factory?
Blockchain, unfortunately, is not my subject, but I know that there are aspects associated with the food plant that one can look at from a blockchain. But it's not my subject, so I would not be able to share much thought on it.
Right. Thank you, sir. Indeed, treat to our ears listening to you give this presentation. Thank you so much for the insights. I now hand over the session to Chinmay Devgaonkar ma'am, President of AFSCI Mumbai chapter, to please formally thank sir and propose a vote of thanks.
Yeah, hi, Sagar.
Hi.
I mean, apologies for the initial, aspects. Am I audible?
Yeah, you're very much audible.
Yeah, thanks. So apologies for just 1 minute. The apologies for the initial hiccup. I know the program started little late at 10 minutes late. But let me tell you, the way you have described it is, I wish that if I would have, learned that at my, college days, the criticalities of a plant design. I mean, as an auditor, when we used to audit and when client used to tell us that these are the findings, that was the time when I personally learned, what are the criticalities of a, plant design. And trust me, participants, you would not have got a better trainer, better tutor, than Sagar, who has experience of designing 600 plus plants. So, and that too from variety, from dry to wet to frozen, from all aspects. Thank you so much. My only question to you, Sagar, before, this thing was, you have talked about regulatory requirement, but then the regulatory requirements vary state to state. Just one last question, that, before we really end the session, how do you feel that, how much difference do you see in the regulatory requirement from the different states, especially when it comes to factory rules? And have you really faced any challenge wherein a process required X and the regulatory said Y?
So that's an interesting question, Chinmay. So when it comes to a food plant, I think the safest thing you can put is put it in a way in which there is nothing that is excluded from a point of view of any standards associated with any regulations of the plant. So what happens is, see, food plant, let's say we have central regulations, all right? So central regulations, it come from a point of view of water, defining the water associated with process, the quality of water, or central regulations come in terms of effluents, the CODs, the BODs, the TSS, the TDS that typically go out. Those are central regulations. So irrespective of where you are putting the plant, central regulations would be same for everybody associated with it. The state regulations are more in terms of subject of on subjects which are more state related. For example, power is a state related subject. Now, you can have a situation where a plant requires 300 kW of power, okay, but in order to ensure the LT and the HT line, okay, transmission line, you therefore have to plan a transmission line. But sometimes we have situations where client says, all right, let's avoid the cost associated with HT or LT line. Let's put 3 different meters for different sections of the plant. So therefore you have those regulations also meeting up, the cost also meeting up, and expectations. So there are ways in meeting the expectations of regulatory aspect and associated aspect. But important thing is, keep in mind, put your plant in such a way that you should be proud to showcase it to whoever are your potential clients tomorrow that are looking to source from that particular plant. And you should be ready for inspection for anything regarding the plant aspect. So put it in a way in which you are proud to showcase your plant, and the key aspect is it's not only about putting the plant, but it's also ensuring the operational efficiencies that come with that putting up the plant.
Perfect. Thank you so much, Sagar. Thank you for this, wonderful session. This will be displayed, this will be released on the YouTube channel of both AFSTI Mumbai as well as CSMB. And this will also come as a part of Reels, on our Instagram account and Facebook account. So thank you so much for your time today. Loved it. I just wish if I would have attended from the beginning, but I simply loved it. It is fantastic. Thank you so much.
Thank you
Have a
so much.
lovely day. Yeah.
Thank you to AFST and
Thank
CSAMB.
you. Thanks. Bye.